Hi everyone, this is Gonzalo here. I'm going to be explaining to you how to create and set up a high availability infrastructure on Amazon Web Services. We're going to be using the services we have been learning on the past weeks on the Enclode's Dev2DevOps course. I have a list of the services we need to configure here, and as you can see, the first thing we need to set up and also to create is a VPC. That's the most important part and the first thing we need to do. So this is a virtual private cloud, and in order for us to create a new one we have to go to the VPC section on Amazon Web Services. On the Amazon Web Services console, you go to VPCs, you go to create, you click on create VPC. You can use the manual you can do it the manual way, or you can use the wizard. This is the new one experience that has been introduced recently, and this one offers to you a preview of how that your VPC is going to look like. So you can create a new, you can set a new name tag for your VPC. You can select the CIDR you want to use for your IPv4, and if you want to use IPv6 or not. In this case, we're just going to leave it as it is. We can also set the availability zones we want to have on our VPC. In this case, we can just leave it as it is as well. And you can also choose how many public subnets or how many private subnets you want to have on your VPC. We need to set a net gateway in order for our instances that are going to be allocated under these private subnets to have access to the internet, and also we need to have an internet gateway that is going to allow to every instance under the VPC to have internet access. In this case, we do not need any S3 gateway, so you can leave this as none, and with this we can go ahead and click on create VPC. In our case, we already have done this. You can take a look at this. This is the VPC we already created, and you can filter this on this section just in order for us to take a look at the VPC settings. So you can take a look at the subnets here, the private and the public ones we have. You can also take a look at the row tables that the wizard created for us. You can take a look at the internet gateway we have here, and also for the NAT gateway. Okay, so now according to the instructions we have here, we also need to set up a network load balancer. So in order for us to achieve this, you need to go to the EC2 section on Amazon Web Services. You can find the load balancer options here on load balancing, and in order for you to create a new one, you have to click on create that load balancer. You can see here a description of the 3 different types of load balancer that Amazon Web Services offers to you, and in our case we're going to be using a network load balancer. So we need to set a load balancer name. In this case, we need the scheme to be an internet facing, because our clients or the users are going to be accessing to our web service from the internet. So also when we are going to specify here, we're going to be using an IPv4 as an IP address type. You must need to specify with your VPC here, so you can just filter by this with using your VPC name, and the availability zones that you're going to be using. As you can see here, we can see this little message telling you that you need to select a subnet that has access to an internet gateway, since this load balancer is going to be an internet facing scheme. So we select the public one here, and the same goes for the rest of the availability zones you want to use. The listeners and routing, that's okay as it is here, since we are going to be using the port 80 on our Nginx configuration. We are going to be talking about this later. So you can see here the summary of your load balancer, and also another important thing that we need to set up here is the target groups. So far we have covered already the VPC service. We are talking right now about the load balancer. We already talked about the NAT gateway and how to set this one. And now we're going to talk about the target group. So the target group is going to help us to, actually it's going to help our load balancer to know which service or which what is it that it needs to balance, basically. So you can see the target types. You can see the instances. It could be instances, it could be IP addresses, it could be actually a lambda function, and this could also be another load balancer, an application load balancer. In this case, for this project, we're going to choose the instance target type. You need to set the target group name, and the protocol could be the one we are seeing here, since as I was telling you before, we're going to be using the port 80 in order for us to expose our web server. As you can see here, the VPC has been chosen automatically, and we're going to allow the health checks because it's going to be a useful thing we're going to be using in a moment. So you click on next. Okay, click on next, and you have to register your targets. At this moment, probably you maybe do not have any instance. You can leave it as it is. You can include these ones later. Okay, so once you have your target group created, you need to specify this one here. As you can see, this one has been already specified, and you click on create load balancer. And as before, we already have our load balancer here created. You can see it here. We can see the type of the load balancer. It is a network one. The scheme is an internet facing. The IP address is an IPv4, and this one provides us with a DNS name. So the web server that we are going to be allocating on the instances we are going to be created in a moment is going to be available or accessible from this DNS name. We're going to take a look at this in a moment. You can see here also the availability zones for this load balancer. So far we already have covered the load balancer and the target groups. So let's go ahead and let's configure the EFS. So what is an EFS? It's nothing but an elastic file system. This is very useful because it helps us to have a scalable file system, and this is going to be very helpful in order for us to have a unit, a storage unit that is going to be able to automatically scale in case we need more storage, right? More space. So in order for us to create a new one, you have to go to the EFS section on Amazon Web Services. You have to create a new one by going here, create a file system. You have to, optionally, you can name this one. You need to select the VPC where this is going to be working, and you can also select the availability and durability. In this case, we are going to be using the regional one, and you click on create. And as before, we already have created this one. We can take a look at this elastic file system details here. By default, if I'm not wrong, this one, the original size, it's 6 kilobytes. Since I already have copied the web server files to this one, you can see here it has a 16 kilobytes size. You can take a look at the monitoring file system metrics here, and you can also take a look at the network and access points. So basically that's what we need for this service. So now we are going to go ahead and set up and create a launch configuration. So in order for us to create a launch configuration, you have to go also to the EC2 section on AWS console, and this is one of the last options you can see here on this left side menu or left side bar here. You have to click on launch configuration. You can see here the ones we already have created. You create a new launch configuration. You have to name this one. In order for you to create a new one, you need to specify the AMI machine or instance that you want to use for this launch configuration. Just to be clear, a launch configuration is kind of a template we used in order for us to create and launch in EC2 instances automatically. This service goes hand to hand with the AutoScalling groups. So we're going to be talking about this in a moment. So in this case, the instance we're going to be using, it's an AMI, a Linux one, but since it's kind of hard for us to find the specific instance we need to use here, you can just go ahead to your EC2 dashboard here, and you can just click on launch instances, and you can just copy this ID we have here from the instance we want to use. So you copy this one and you can paste this one here, and it's going to find this automatically. The instance type is going to be the free tier. As you can see here, this is a T2.micro. So you can just type T2 here and select the micro one. You click on choose. If you want to set an IAM role actually here, you can select a specific one if you want to. In this case, we are just going to leave this as it is, and we're going to be also setting the user data. So let's recapitulate. Since we created an EFS, the reason we are creating this is because we are going to be using that storage unit to storage or to save our web server files. So in order for us to move the web server to our EFS, well, at least what I did is I create one EC2 instance under a public subnet on my existing VPC, the one we just created, in order for me to mount my EFS and to copy my web server file. In this case, as I was telling you, it's just an index HTML. So you can take a look at this one here. Here is where I am connecting to this. This is just a temporary EC2 that I'm using, and in order for me to use this is another AMI EC2 instance. I have to basically follow these commands we have here. These are pretty much the same we're going to be using under the user data section on the launch configuration. So I have to install the EFS, Amazon EFS utils tools in order for us to mount our EFS in this instance. So once we have this installed, you can go ahead and mount the EFS. So as you recall, once you create an EFS, this one provides a DNS name. So this is the one we're going to be using in order for us to identify our EFS, and also this is going to be useful for us in order for us to connect or mount this one to a specific instance. Like, that's basically what I'm trying to do here. And what I'm doing here, it's I'm just going to be mounting this, and since at this very moment the only thing that is on this EFS drive or unit, it's just the HTML file that I'm telling you. We can confirm this by getting connected to this instance. You can see this was the directory that I created to mount this EFS. But at this moment, if I'm around, this is not mounted. Let me take a look at this. Oh, actually, yes, it is mounted. So as you can see here, basically this is what we are doing with this command. We are telling this the instance to mount the content that is on this EFS on this specific directory, that is where Nginx stores the HTML files. This is going to be save us some time in order for us to expose our web server on the default Nginx location. So if we take a look at our directory here on this temporary EC2, we can see here that we have the EFS mount point at this location. So if we actually access to this one, we can see the index.html file. You can see here, as I was telling you, this is basically a calculator. We can take a look at this one in a moment. So that's the only use I'm giving to this temporary instance here. This instance that I use to move my indexed HTML to my EFS unit, it's the one that we can see here. Let me see. It's this one. So at this moment, since I already have copied the files that I need to in order for me to get my web server running, it's successfully done. I can terminate this instance. We're going to be doing this at the end. So now, once we have that files for our web server copied to the EFS, we need to go here to our user data. As you know, this is just as we can use this with a bash script. That is basically what we have here, and this is going to be executed when the new instance is going to be created automatically. So everything we put on this command, on this user data, is going to be executed on the creation of the new instance. And so we can set the web server. I mean, we can set up the web server here on the launch, on the go, basically. So this is what we're going to be placing here on our user data. The next is to, let me see, only assign a public IP address to instances. Okay, we can leave this as the default one. The volumes, we can add a new one. At this moment, since we're not going to be installing many things, we can just leave the default 8 gigabyte size. The security groups, we need to select an existing one, and we need to choose the security groups we have under our VPC. You can also get this by using the VPC ID or using the security group ID. And we need to choose our existing key port, and in my case it's this one. So after this, you can go ahead and create a launch configuration, and as I was telling you, this is basically just a template that we are going to be using with an AutoScalling group. So an AutoScalling group is going to allow us to have this part, to cover this part, the failure tolerant. So let's say if by mistake any of the instance we have here under our load balancer is deleted, or one of these it's not working properly, this one is going to try to actually is going to create a new one. So what we have to do here in order for us to create a new AutoScalling group, it is under the same EC2 section. You have to go to AutoScaling. You can see the AutoScaling groups option here, and you have to click on create an AutoScaling group. You have to set a name for this one, and then you have to choose well, you can choose here either a launch template, or you can choose a launch configuration. In our case, we are using a launch configuration, so we click on switch to launch configuration, and we need to select the one we have just created. In our case, is this one. As you can see here, this is the name I gave my launch configuration. You click on next. Okay, let's just put a temporary name, and you have to also select your VPC. So my VPC, it's right here, and you can actually choose all of your availability zones, but our instruction says that it's just going to be, the instances are going to be deployed only on the private subnet. So in this case, we are only going to choose or to select the private subnets right here. So after this, we click on next. Now we need to attach a load balancer. So we're going to go ahead, click on attach to an existing load balancer, and we need to choose a load balancer from our target groups. So as you remember, we created a target group that is right here, that is also linked to our load balancer. These health checks, we can leave it as it is, and we click on next. Now here, this is another thing that it's also specified here on the instructions. It says that the AutoScaling group must have a min capacity of 1, so this one stays, or we leave this one as we can see it here by default. Then the maximum capacity is going to be 2, and also the desired capacity is going to be 2. So we change this, and the scaling policies is we're going to leave this as none, since we are not applying any policies at the moment. We click on next. If you want to, you can add some notifications here. At this moment, we do not need this, and we're not going to be creating any tags. So after this, you can see here a summary or a review of your actual AutoScaling group that you're about to create. So if everything is correct, you click on create AutoScaling group. And as you know, we already have done this, so we can take a look at our AutoScaling group here, and you can see here the details of this one. As I was telling you, we have the desired capacity of 2, minimum capacity of 1, maximum capacity of 2 as well. We have here the launch configuration and the security groups we defined before. But as I was telling you, it's just the private ones. The private subnets here on the network, and the availability zones that are linked to these subnets. We can see here the target group that is also related with our load balancing. So after this, once you've done this, you can take a look at the instance management section here, or tab here, and these two instance management, these two instances you are seeing here have been created automatically. We can take a look at these ones here. These two are the ones that were created, and you can also take a look at these from the target groups. This is our target group. You can take a look at this from your EC2 section, and you have to look up for the target groups right here. Since we allow to have the healthy checks, you can see here if your instance is healthy or not. If by any chance you can see that one or all of your instances are unhealthy, it could be that maybe on your security group you do not have the specific rule to allow traffic on this 80 port. Or it might be that you actually do not have your Nginx set up properly on your user data script. So let's terminate one of these instances just to make sure this one is working properly. So we successfully terminate this instance, and also I'm going to be deleting this one that, as I was telling you, was just created. It was just a temporary instance just to copy the files that I'm using on my web server to my EFS. So let's terminate this one as well. So now if we go back to our scaling group and refresh this, let me see. Okay, this is still on shutting down. It's going to take a moment. If we refresh this one here, it's still unhealthy. I mean, it's on a healthy status. Let's refresh this. So in the meantime, while this is complete, let's go ahead and talk about one of the last services we are using, that is Route 53. This service allows us to create or a specific domain name. So in this case, we need to use the one that is already here, that is training-nclose.com. So we just need to go ahead and create a record. You need to set a name for this one. You have to choose the record type. In our case, we are going to choose the first one, and we're going to be using an alias. In this case, we are using alias to network load balancer, because that's the type of load balancer we are using. Then we need to specify the region, and as you recall, we are on Oregon. So now we're going to be able to find out our load balancer, as you can see here. And as simple as that, that's how you create a DNS. And we already have done this, as you can see it here. So now let's go back here to the instances. As you can see here, this has been terminated successfully. So if we refresh this one here, we just have one here. But as you recall, the AutoScalling group rules is that we need to have two desired instances, and also the maximum capacity is 2. So now at this moment, the AutoScalling group is going to it's going to launch another instance with the same configuration that we specified on our launch configuration. So basically that's how this works. So we go ahead here and check on the instance management tab, and if we refresh this here, you can see here this one is the one that we just terminated, and one of these two is the new one that has just been launched. We can take a look at this here on the EC2 Instances dashboard. This one that says initializing is the new one that has just been launched at this moment. We can confirm by checking the instance ID here with the one we have here. And also we can take a look at this on the target groups just to make sure that this one is a healthy one. As you can see, since at this moment this is initializing, the initial health checks are still in progress. Once this is up and running, just as the other one, we should be seeing here the health status as healthy. If there is any issue, we are going to see the status as unhealthy. So now let's make sure and confirm that this is working. So we have actually two ways to access to our web server. As you know, our load balancer provides one DNS, or where we can actually access to this one, and it's this DNS name. So if we go ahead here, you can see here, this is the page that I was talking about. As you can see here, that's my name, that's the homework, the course. We have here a little infrastructure architecture for this high availability one. And this is kind of the same one we are doing. You can see here there are about 53 DNS. You can see here the load balancer. You can see the web servers that are under the private subnets with the NAT gateways in order for those ones to have access to the internet. So this page basically, as I was telling you, is just a calculator. At the moment it only adds numbers. So let's say we want to add 3 plus 3, it's going to be 6, as you can see it here. Okay, now we access from the load balancer, but as you can see, this load balancer URL is not so friendly, right? So that's the reason why we are creating a route 53 DNS. So if we go ahead to this DNS, we're going to be able to access to the same page that we have on our load balancer. And now let's just make sure that everything is working properly here. As you can see here, the new instance has just been relaunched. Has just been launched actually, because it's a new one. It's healthy and it's up and running. So that's how we can set up properly a high availability infrastructure that is also failure tolerant. I hope this video helps you to create good high availability infrastructure using Amazon Web Services. Thank you for watching.